Okay, wait. Okay, so yesterday I think we did it till here. If you guys have any questions, please do let me know, right? Okay. Now, uh, we're gonna go a bit forward, right? And we're gonna look at two different cases of motion in SHM, right? Now, you don't really need to remember how I'm deriving these equations, but it's better that you remember that the final form, basically. So helical spring basically is the normal spring that you see every day, but basically this sort of spring moves up and down vertically, right? So suppose that it has a value of k, which is the spring constant. You guys might know already. And basically this is the mass m. And of course, when it moves up and down, so there has to be some tension force there, okay? This force, T, is basically given by F equals to minus kx, and the negative sign is because negative shows that it opposes tension, okay? That's why, because it wants to come back, right? Now, usually when springs are, oscillated, so we should remember that basically they follow simple harmonic motion. That's why we're going to use A equals to minus omega square x. Now tension, which is equal to ma, right? We can put it like this, that tension, which is equal to, right here in a helical spring, minus kx equals to m, and A is minus omega square x. So I just put A in this equation, okay? Now, if you look at it, x and x is going to cancel out. This means that this is going to be minus k equals to minus m omega square. I can just write it as m omega square. Now, please check this out. What then I can do is I can make omega the subject, and if I do that, it is going to be k upon m, and there is a square, so I can take root of both the values. So omega is going to be k upon m under root, like this. Since we know omega is 2 pi upon t, or you could simply say 2 pi f, right? So you can use both of them to find the time period of helical spring. And when you do that, you can replace omega with 2 pi by t, k upon m root. So the time period then can be written as 2 pi, and here, because I've taken reciprocal, so m will be on top, k will be on bottom, like this. So this is one equation you can find time period with. And if you really want to find the frequency, so frequency will be 1 upon 2 pi k upon m. So that would be the same thing, and it can be simply derived like this. Now, it's very rare that this question comes, but if it comes, you should remember that you just need the spring constant and the mass that is loaded onto the spring, and you can find the frequency and time period of any spring whatsoever, okay? If you have any questions in this, please let me know.
Sir, could you repeat the last 4 steps? Your voice broke while you were explaining.
You mean this ones?
Yes.
Okay. So what I did was I just took under root here, which led me to omega equals to k over m, like that. And then because omega is 2 pi by t, this is from the very first chapter, circular motion, right? Or omega is 2 pi f. So we can replace omega with 2 pi upon t equals to k over m. If I take reciprocal, right, so t will be on top, 2 pi will go there as 2 pi, and then when you take a reciprocal, m will be on top and k will be bottom, right? Is it clear?
Yes, sir.
And then if you want to find, if you put omega, instead of omega you put 2 pi f, then f will be here, 2 pi will divide there, and the rest of the equation will be the same. So you just need to know these two, and they're very not really important. Okay, is it clear, everybody? Please let me know if you do.
Yes, it's
Okay.
clear.
Okay, now I just want to give you one more equation that is for a simple pendulum. So a simple pendulum would basically go like, say, this way, and it would move a displacement s, let's suppose, when it is exactly vertical. So let's say this is the angle theta it moves, and this is the length of the pendulum. So the acceleration due to gravity always acts downwards, as you guys already know. So for this one, I just want to tell you that for theta to be very small only, okay, make sure that's very small. So you just need to remember that t can be written as 2 pi L over g, which is the length, and g, and frequency will be basically 1 upon 2 pi g upon L. So these are the two formulas which can give you the time period frequency. And honestly, these would not really matter. You just need to remember that this is the acceleration due to gravity, and this is the length of pendulum. That's it. Both formulas are very similar. You just need to switch the values. That's all. Okay.
Sir, do we need to know the derivation for these two?
No derivation. Nothing really required. Okay. Now, and this is like 1% chance that these comes, because they did not remove it from the syllabus recently. So I'm really not sure whether it will come or not. But still, to be on the safe side, I just teach it. Okay. Now the real thing that we're going to do is the graphical relationship, and a lot of questions about this will come. Graphical relationship between displacement and this. Now, acceleration. So what you're going to do is you just need to remember that basically the equation that we're following right now is basically a equals to minus omega square x. Now if I put acceleration on this side, which is basically in meters per second square, positive, and here acceleration negative, meters per second square, on this side I could put displacement as positive, negative displacement here. So according to this, you guys need to remember that no matter what kind of graph comes, you should remember that when you compare this with the math equation y equals to mx, so you realize that basically on the y-axis you got acceleration, and on the x-axis you got displacement, which means that the gradient here would be omega square. Now the important thing is this, let me write it, gradient will be equal to minus omega square. So first of all, the thing is the gradient is negative, and y is equal to mx basically shows a straight line that starts from origin, which means that when I'm drawing this line should look like this actually. Okay, so which would actually mean that, and you can actually see this too, this point has to be 0 and 0, by the way. So if you look at it, that when the acceleration was maximum, so this is a naught and it is positive, so you might see that here, exactly here, you have minus x naught, which is the maximum displacement but in the negative direction. And here, when the acceleration was negative maximum, then the displacement was basically positive maximum. So this graph will always be like this, and you just need to remember this and nothing else, right? Okay, now then we're going to look at basically the graphical relationship between V and W, and then I'm gonna show you some questions. Graphical, well, let's, instead of first, let's write relationship between velocity and displacement. Okay, now this is important. Now when you open the exam paper, right, so there is going to be a formula sheet there. Within that formula sheet you will see a formula that's already given, right, and you don't need to remember this. This formula is V equals to plus minus omega and under root x naught square minus x square. Now this has a bit of derivation behind this that we don't need to do it, and we're not going to waste time. But if you want me to do it, we can do it after the class. Just for your understanding, it is not a big deal. In this formula, I just want to tell you that this is basically the velocity, this is the angular frequency, you could also say speed if you want to. This is basically the maximum displacement, and this is the displacement at certain velocity, right? So this is basically the equation you guys need to remember. All right, now I just want to tell you, if you guys have written it, wait a second. When you open any paper, right, well, let me open, okay, this one. So you will see in the data sheet, this formula is already given, and you see velocity of particle in SHM here, and the formula is given, V equals to plus minus omega x naught square minus x square. So you don't need to even remember this, but it's good to remember. I mean, nothing harms you there. Now, yes,
X squared is displacement at what?
at certain velocity. Okay, it could be any velocity. Like basically what it means is that basically, let's suppose the pendulum is here, right? So pendulum max points are here. Let's suppose the pendulum is here right now, so it will have a certain velocity and a certain displacement. So we are talking about this displacement. This displacement is x naught. Do you understand? Like that. So for any velocity you can find the displacement, or for any displacement you can find the velocity at that point. Is it clear?
Yes, I got it.
Now one thing I just want to tell you, and that is important. When you look at this formula, right, you can say okay, what will be the formula for maximum velocity, because we can find maximum acceleration displacement from there. So what could be the maximum velocity? So we need to remember at maximum velocity, and if you remember, I told you at maximum velocity the displacement has to be 0. Remember?
Yes, sir.
This means if you look at this formula, let's write the maximum velocity v naught plus minus omega. X naught is going to be still the same, right? Because that's a fixed value. But now we're going to put 0 instead of x, because at maximum velocity this is like that. And v naught will be equal to plus minus omega. And this basically x naught square cancels out. So we end up with v minus omega x naught. Do you guys have any idea where this formula comes from? Those who have actually studied from me, you guys remember this formula? V equals to R omega from the first chapter. Basically, this is the same thing, that for maximum velocity of anything, when it is moving in a circle or any simple harmonic motion, you just need to know its maximum displacement and the angular speed. You can actually find it. Okay, so you just need to remember this now. So from this point onwards, we can then find the graphical relationship. And then we're going to look at some questions which are super easy. So we are going to look at graphical relationship between this. Now, why do you need to know this? Because a lot of things you need to learn by rote learning. Because a lot of times calculus isn't in our course, and then you might be like confused if you try to get into calculus. So you don't have to. You just need to learn that what type of graphs these will show you. So if your velocity meters per second here positive, and velocity meters per second negative, here you have displacement in meters positive, here you have minus displacement in meters. Now just remember that this graph will be a circle, exact circle. Okay, this doesn't look like an exact circle, but let me just try to make an exact circle. Well, okay, this is too small, doesn't fit my purpose. Oh no, what do I do? Wait. Okay, fine. Okay, just don't mind it. Okay, if it's not a perfect one. Okay, so you guys need to remember that the relationship between this is because the equation for v is equal to plus minus omega x naught square minus x square, and basically keep on putting the values, you're gonna get the circle. But the thing is that if you look at right here, you will see this is v naught, and when there is v naught, you might see that x is 0, as you can see, and when it is minus v naught, again x is 0, right? Here where you see x naught, you might see that v is 0, and when it is minus x naught, you see v is 0. Is it clear, everybody?
Sir, how can we relate this to the equation?
This one basically,
I mean, this graph and this equation.
So basically this graph forms from this equation. So you can keep on putting the values right into this, and it will give you a particular value. Like for example, if you have certain velocity right here, crap. Let's suppose you have a velocity that is right here. Right here. Okay, so v. So you go here and you want to know exactly what is the displacement here, right? So basically, if you want to know, if you have the velocity and you have the maximum displacement and the angular velocity, you can find the displacement and you can draw the graph. So this graph basically comes from that you keep on adding the values of displacement, like 1, 2, 3, 4, 5, and like that. And then for each value, you're going to get a new velocity like this. Is it clear?
Okay, sir, got it.
So basically, this equation, if you even try to use computer simulation, right, for this equation, it will give you a circle. That's why we just need to remember this. We don't have to get into drawing it by point. We just draw it as a sketch. Is it clear?
Sir, so if we get a question, we can just draw a circle, right?
Yeah. And that is the reason, because I want to answer your questions. I would like to show you some questions from the papers, that how they're going to ask you these. So for that, you would just gotta wait like 2 minutes. Let me paste it, okay? While you copy this. And if you miss something, please let me know. So 1, 4, 3. As I said, when you have enough practice of these questions, right, you will be like, what is this chapter even? Because a lot of things will be just rote learning. And if you remember, you can solve it. If you don't remember, you won't be able to. Okay. Ah, okay. Now we need to do a full question actually. Hold on, please. Putting it in. Okay. I hope it's loaded. Yeah, it is. Now this is the first question, right, that I just want to show you. So just by looking at the graph, can you tell me what is the equation of this graph? Yes, bacho. Any equation you know that represents this graph? Nobody knows. That's too bad.
Y is to negative x. Equal to negative omega square x.
Yes. So you already know this, right? And now they say state two features that show the motion of cone is simple harmonic motion. So what are those features? Can somebody please tell me? I did tell you about the features just now, about this graph. Number one, that graph starts from origin, which means when acceleration is 0, displacement is also 0. Do you guys understand? The other condition is shows a
negative gradient.
yes, very good. Now you guys understand. So everything that I write on my notes, it means it is going to be there. Okay, so please do remember that shows negative gradient. Okay, so I missed E. Negative. Okay. Now let's go to this. Now it says use the figure to determine the frequency in hertz vibration of the cone. Now we already know that the only way I can find the frequency is from omega, which is 2 pi by f, and to find this I know I need to take the gradient, right? So I can always take 0 as your first point, and then you can take the other point as this one, which is 750 and minus 0.3. So acceleration is 750 at this point and x is minus 0.3. So let's find the gradient, or you can just put
minus 2500.
Yeah. Are you sure? It won't be minus. I don't think so it will be minus. So 750 minus omega square minus 0.3, right? Minus minus is going to cancel out. So 750 divided by 0.3 is omega square. And that is, I don't know,
2500.
2500. Omega is 2500.
No, omega square is
Yeah, okay. And then omega
is 50.
Okay, and then we need to find the frequency, which is omega is 2 pi f. So 50 divided by 2 pi is the frequency. Can you do that? Oh, we need to find frequency. Sorry. Go on, please.
7.95.
7.95. 7.95. Okay, doesn't make sense to me because it's 250. Let me check. There is some mistake I might have done. What mistake?
7.96.
Oh no, I know. No. Actually, the mistake I've done, I can see. The mistake is that basically I didn't see, and it's weird because it's millimeter here, and I need to convert this. Sorry. So now I need to do 0.3 minus times 10 raised to minus 3. Now everything changes. So can you do now? 750 divided by 0.3 divided by 10 raised to power minus 3. Okay, so this is a rookie mistake. You guys should not do it. Only I'm allowed to do it. Okay, 2500 and 0, 0, 0, right? And then under root of 1250, 0, 0, 0, that's 1581, and then 1581 divided by 2 and divided by pi. Okay, so that's basically 251 hertz, 252 basically. Is it clear, everybody? Like that. Any questions? Please let me know. Okay, now let's move forward and moving to the next question. So this is pretty simple. Let's go to this one. Who's going to tell me the definition of SHM? 2 marks only. I guess I told you the 2 marks. Yes, please.
The magnitude of acceleration is directly proportional to the magnitude of displacement.
Yes, magnitude of acceleration. Don't be lazy like me. You have to write the full. Okay, I'll write the full thing too. Acceleration is directly proportional to magnitude of displacement, and
acceleration is always directed towards the main position.
Acceleration is always directed to the mean equilibrium or mean position. Yes. Very good.
So we write it as 2 separate points or together?
You can write it at 2 separate points. They will always give you the marks. And basically, when I used to be a very bad student actually. Let me tell you this. And whenever I would not know something, right, I would write really big essays with bad handwriting so the teacher couldn't get it. But still, it doesn't work here. They will check the marks. So it's better if you know this, you should write in points. It's always good. All right, now, if you look at this, they have given a graph. And now they say, state one time at which the trolley is moving through equilibrium position and also the next time that it moves through this position. What time would the trolley be at equilibrium position? Maximum velocity or zero velocity? Who's going to tell me this?
Maximum.
Maximum velocity. So the time maximum is this one, and this one, and this one, right? So it says first and second. So first is this one, which is 0, and the second time it goes maximum is this one, which I believe
Sir,
is
how do we know we have to take maximum velocity?
because at equilibrium you should remember that acceleration is 0, displacement is 0, velocity is maximum. Remember?
Okay.
So first point is 0 and the other point is, I don't know, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. So 0.6 and half. What is that? 0.65. Okay, that's fine. All right. So just be a bit careful. Let me check. It's even in the middle, so I don't know. इसका भी half होगा 0.65. Okay, now. So we got this. Now it shows you this. The amplitude of the vibration. Amplitude means the maximum displacement, right? So they have already given you this. Do you know how to find the maximum velocity with the maximum displacement? Who knows the formula in this class? V naught equals to omega x naught. Even if you don't remember, right, you can just use this one. It's fine. And now what you do, you want to find this. Do we have omega? We don't, right? But omega can be found out by 2 pi by t times x naught. So 2 pi, and we can find the time period. So time period is this one, from here to here. So that would be 1.1, 1.2, 1.3, 1.25 would be the time period. So 1.25 times x naught. I'm gonna convert this into meters. So let's do it, and then we'll check the answers as well. So 2 pi shift 2. Oh, by the way, if the meeting ends right in 2 minutes, you guys need to rejoin. 1.25 times 3.2 times 10 raised to power minus 2. So this is basically 0.16, right? 0.16. Oh no, wait, this was in centimeters per second. My bad. So we don't need to convert it. I hate them. Okay, so this will be 16.1 meters per second, centimeters per second. Okay. Then says the displacement of trolley for the speed of half V naught. Half V naught, right. So now we're going to use the formula V is equal to omega x naught square minus x square. So half V naught means I'm going to put half V naught here. Omega is 2 pi. Just remove this. When you remove this doesn't really matter. 1.25 and root of root of x naught square, which is basically 3.2 square minus x square. We want to find the displacement at this point. Interesting. Okay, never mind, let's put it, I got an idea. Let's put it here. And what you do now, instead of V naught, we can write, even keep this as omega, we can write V naught had an equation V naught x naught omega x naught omega under root x naught square minus x square. Omega cancels out with omega, and now I got something like this. So to do this, I can square this up. If I square this, it is going to be a quarter x naught square equals to x naught square minus x square. Okay, so I'm going to take x square here and then x naught square minus 1 by 4 x naught square, and I'm going to put the values 3.2 square minus a quarter 3.2 square. Okay, and that's x square. Okay, this is interesting. 3.2 square minus okay, right. Okay, I'm sorry, the meeting ended. Now, did you guys miss it or should I do it again?
No, sir, we got it.
Okay, so now we're gonna just put in the x naught values, and this will be 3.2 square minus 1 by 4 times 3.2 whole square. So I'm getting it as x naught equals to 7.68, and then I'm going to take under root of this answer, so that is going to be 2.8 actually. Is it clear, everybody? Any questions?
No, sir.
Okay, now going to this, use your answers in B to sketch on axis graph to show the variation of displacement x of velocity v. Now, who's going to tell me what would be the shape of the graph? This will be a loop. Okay, it will be like this. Okay, now, so we have v naught, which is 16.1. You don't really need to do anything. You can just take this as 1 2 3 4 4 1 2 3 4 8 1 2 3 4 12 1 2 3 4 16. Okay, so you got 16, and right here this is minus 16. Okay, when you do this, you just need to remove it or you don't remove it, doesn't really matter, should be the same way. Now v naught is this one, so you would put point right here, and x naught was basically 3.2, right? So you go to 3 is 1 2 3 4 5 6 7 8 9 10 na? 1 2 3 4 5, so this will be 3, and 3.2 will be this point. Okay, this point is 3.2. 1 2 3 4 5 3.2. This will be minus 3.2. Just write 3.2 and minus 3.2. And then what you do, with this very smooth hand, you just sketch a circle. Whether it's exact circle does not really matter. It must pass through the point.
Sir, we do use the values, right?
Yes, of course. Of course.
But you said we could just sketch a circle.
I mean, you're not supposed to find every value on the circle, just the maximum ones, right? Because you need to, do you understand? That has to be there, but the thing is that it can be, it should look like a loop, should not find every value from the equation. Is it clear now?
Yeah.
So now I believe you guys basically can understand how this works, right? And both of the graphs will be there all the time. So whenever you see v and x, you should always be sure that okay, it's going to be a loop, and whenever that is going to become there, you should remember that okay, it's going to be a straight line with the negative gradient starting from origin, right? Now let's check out their answers, because I'm not even sure. So this is October, November 09, 2009. Okay, let me use the keyboard instead. October, November 2009, winter 2009 variant 42. Okay, market schemes, variant 42. Okay, question number 3. So question number 3. Okay, so first answer should be 250 to two significant figure. Our answer is 252. That is correct. Straight line through origin and negative gradient. That is correct. And then I cut one part basically. Okay, and then the other question was from October, November 14, 2014, and 43, winter 43. Okay, so, and question number 4. Okay, so you see first they also given you a point. They say acceleration force proportional to displacement from fixed point, and they say either you're gonna write acceleration and displacement in opposite direction, or acceleration always direct towards the fixed point, which is the main point, right? So I have written this, you should remember this, and then there are a couple of answers where you can write 0 and 0.625, which we got, so that's fine. And then you see we got 16.1, that's great. And then displacement was 2.8. And then in this one they say sketch loop with origin at its center, correct intercept and shape based on this. So your shape should be like this. Is it clear, everybody? Any questions? So they don't want you to go into any complexity, just remember this. All right. Now 50% of this chapter is completed, right? And how much time we got? 3 minutes basically. Let me see if we can do something else, or should I give you a question and early off? Let me think about it. We need to do energy. Okay, what I'm gonna do is I'm gonna give you one question instead of going on, because the topic is not going to complete then. Wait a second, please.
So why is this your favorite topic?
My favorite, because it is the easiest topic. When you